Yes, my name is Chizito Ryan. Previously, we had talked about our problem as we continue to delve into this journey of machine learning. And for our problem, which is burglary and vandalism detection, our solution was that we wanted to provide a real-time solution where one can deploy a model through CCTV or surveillance systems to detect burglary or vandalism in real time, as opposed to the previous and prominent inventions in this sector of security that only offer post-event maybe analysis. So yes, we looked at the EDA previously, where we explored our data set, what constraints it would give us concerning the models we want to train, what were the dominant classes, and we saw how that went in the previous video. So today we will be focusing on methodology and system architecture. So yes, for my first model, for my first type of model, I chose the convolutional neural network combined with long short-term memory, both of which are neural network techniques. And the purpose of this is to analyze surveillance videos and classify them as according to our target classes, which are burglary, vandalism, or normal. And this starts with firstly video input, which is the first step. The system receives the raw footage or surveillance that is real time. That would be real time if the model is deployed, but now it is from a data set. And since neural networks cannot process entire videos directly, the video is first broken down into individual frames, or what you would call frame extraction in the next step. When you go to frame extraction, you realize that at this point, the video is converted into a sequence of image frames. And for this project, a fixed number of frames are sampled from each clip so that the inputs have the same size. So the purpose of this is basically standardizing the number of frames to ensure that the neural network receives consistent input during training, that it is not biased. And that takes us to the next step, which is CNN feature extraction. And here, each frame is then passed through the convolutional neural network, or what you would call in short CNN. And for my implementation, I use the pre-trained CNN that is based on the RESTnet 50 architecture, so as to avoid training the model from scratch, so that it doesn't take most of the time learning patterns or extracting features, learning features, but it just starts to understand from the features in my videos. Because here the CNN will extract, of course, the spatial features from each frame, and these include important visual patterns. For example, you would say people, cars, or broken windows, unusual movements. And for example, it may detect a person standing near a car, a raised arm, maybe let's say holding an object, let's say a bar, or damage to property. That is all feature extraction. And that takes us to the next step. After those features have been extracted, what happens next? That after the features extracted from each frame, those features are arranged into a sequence and they are passed into the long short-term memory network. Basically, long short-term memory is basically it's a recurrent neural network designed to learn patterns over time. And the purpose of this is that it allows the model to analyze how events unfold across multiple frames. For example, it can recognize a sequence, let's say, such as a person approaching a vehicle, maybe breaking a window, maybe someone reaching inside, reaching inside. That is how basically how long short-term memory works. It's just that simple. It's just a recurrent neural network. So after the patterns have been picked, the model can then go on to classify them, which takes us to the next step, which is the fully connected classification layer. And at this layer, the output that is gotten from the from the LSTM or the long short-term memory, whatever sequences have been learned are passed into the a fully connected layer, which performs the final classification. And this gives us the output or prediction of the model, as you would say. So basically, this architecture works by firstly understanding what appears in each frame using a CNN. That is basically frame extraction, then feature extraction, and then it goes on to learn the sequence of the features. And after that, it can then go on to perform classification and give you a prediction. Basically, that is CNN combined with long short-term memory. It's not, I wouldn't say it's the most efficient, but since considering the size of my data set, yes, it works. It gives a fair validation accuracy. It gives a fair validation accuracy. So yeah, I think we'll move on to the next one, which is architecture model type 2. And this is the two-stream convolutionary neural network. It's still CNN, but this time it's a two-stream. And of course, it also works in the same way. Firstly, the video input. The model first receives the clip from our dataset since we have not yet deployed. And each clip contains surveillance footage from each or any of the classes. And of course, it begins by frame extraction. Sorry about that. The video has to be broken down into individual frames, just like in the first type of model. These frames will allow the model to analyze the video visually, similar to how humans observe motion frame by frame. It's like observing a continuous image, which then turns out to be the video. So yes, firstly, it from frame extraction has it then splits into, and one of them is the spatial stream. The spatial stream processes the RGB frames. This stream focuses mainly on identifying objects and scene appearance, things like cars, people, doors, or building. It's mainly interested in objects and scene appearance. On the other hand, when you go to the temporal stream, this processes optical flow images, and these mainly represent motion between consecutive frames. So yeah, it mainly highlights movement patterns, such as, let's say, you would give an example if it is burglary, a person smashing a window, smashing maybe, let's say, a car window, or let's say forcing open a door. Yes. And of course, it goes on to feature extraction. Each of these streams will use a pre-trained convolutional neural network. For my case, I used ResNet 18 to extract the visual features from the frames. These networks will transform the raw images into future vectors representing meaningful patterns. And that takes us to the next step for each of the two streams, which is future fusion. And the outputs from the spatial and temporal streams are then combined together. That is future fusion. That is after future vectors have been, after the raw images have been converted into future vectors. This output is then combined together. This allows the model to understand both what objects exist and how each of those objects moves, which will then take us to the what you would call classification, where these features are passed through a fully connected classification layer. The model can then finally predict whether the video is burglary, vandalism, or just normal behavior. That is through the softmax layer. Yeah, I think this would be better for our project because oftentimes it involves, oftentimes if you look at surveillance tasks, they involve distinct motion patterns, which I think most of the standard image models like basic CNN may fail to capture. They may fail to capture. Yeah, so far, those are the two types of architecture I have tried and trained models for. Thank you so much.